Good evening, everyone. I hope y'all can hear me. Um, Thumbs up if you can hear me. I believe y'all should be able to react. Okay, great. I hope y'all having an amazing night. Okay, so my name is Rikicha Antonia Prosper. I am a math education major. I am one of the contestants in the Miss and Mr. UB pageant. So I hosted the session to, assist y'all with getting more prepared for test one. So, and I also created a mathematics 140 resource for y'all to use. So stick until the end to learn more about it. So without further ado, we're going to get started. Okay, just making sure y'all can see my screen. You can send in the chat if you can see my screen, please. Yes. Yes. Okay, great. Okay, great. Okay, so this is a past tense work paper. I believe this is fall 2025. So you're going to start off your true and false question. Also, if you have any questions, you can save them until the end, and then I'll unmute the mic so you can ask your question. So just make sure write the question number, and then the question you have, and you can save the question for the end. So determine whether the statements are true or false, then write TRF on the line provided in front of each statement. The reciprocal of -3 is 3/1. Okay, so to find the reciprocal of a number, you just like, if you have a number, let's say A, right? The reciprocal of A is would be 1/A, if you get what I'm saying. So the reciprocal of -3 would be -1/3. So this is true because it's what it had. And to confirm is if it's the reciprocal, all you have to do is multiply the two and it should total 1. So -3 times -1/3, that would be -3/3, -3 over -3, which would just be +1. So this would be true. The number 0 does not have an opposite. This is false. The opposite of 0 is 0. So for any integers n and m, and a is not equal to 0, a to the power of n times a to the power -n is equal to a to the power n minus n. This is true. This is a law of exponent. Did I stop sharing my screen? I don't know why my screen stopped sharing just now. Okay, there you go. Okay, this is the law of exponent, the product rule, and this is true. So when you have x to the power of 1 times, let's say x to the power of -2, is equal to x to the power of 1 minus 2, which is equal to x to the power of -1. And you know, x to the power of -1, that leads to the negative exponent rule. Put the x in the denominator to make the exponent positive. Okay, so for all real numbers a plus 2 divided by 2 is equal to a plus 1. So if I was attempting a question like this, my first step would be to find a number. I just pick a random number and test it out to see if it's possible for that number. So it's saying for all real numbers, so 1 up until infinity, is saying that this equation is equal to that. So let's pick a random number. Let's pick 2. Okay, so 2 plus 2 divided by 2 is equal to 2 plus 1. Now let's simplify both. 2 plus 2 is 4. That's 4 divided by 2 is equal to 3. 4 divided by 2 is 2. 2 is not equal to 3. So this is false because this isn't true for all real numbers. Because since it wasn't true for 2, then it can't be true for all real numbers. Okay, so for all real numbers A, the square root of A squared is equal to A. That is false. It equals the absolute value of A. Okay. The linear equation 7x plus 1 is equal to 7x minus 1 has no real solutions. Okay, so for this, you want to solve for x to c. So if we have 7x plus 1 is equal to 7x minus 1, we want to send all the x's on one side and all the constants on one side. So let me bring this 7x over. And to do that, you transpose. So since it's a positive over here, to bring this over here, I'd have to subtract 7x from both sides. So that's 7x minus 7x plus 1 equals 7x minus 7x minus 1, right? So now we have 1 is equal to negative 1. You see what's going on? That that shouldn't be happening. So that's false. Sorry, no, that's true. Since it's no real solution, since it's not equal to each other, that is true. No real solutions. Because there's no number 1 that's equal to negative 1. There's no such number that exists like that. So that's why it's no real solutions. Okay, so the equation, the absolute value of x is equal to negative 1, has two real solutions. This is false because the absolute value can never be negative. If if you remember absolute value, when you take the absolute value of something, it's always positive because absolute value is just the distance between that number and 0 on the number line. So it's always positive. So this is false. Okay. If negative 2x is less than negative 4, then x is less than 2. So there's something you'd have to actually simplify. So we have 2x less than negative 4. So, and we have a inequality like this. We want to isolate x. To do that, we'd have to divide both sides by negative 2. Because this negative 2 is being multiplied by this x, to isolate x, we have to divide the negative 2 out of it. So dividing by negative 2, what you do to the left, you have to do to the right. We'd have, since we're dividing by a negative number, the sign flips. So now we'd have x is greater than negative 4 divided by negative 2 is positive 2. X is greater than 2. And that's not what this is. This is then x is less than 2. No, this is false. X is greater than 2. Okay, the compound inequality x is less than 1 and x is greater than 0 has no real solutions. If I see something like this, I would just draw a number line and see. So the saying x is less than 1. So let's draw our numbers. We have 0, 1, 2, negative 1, negative 2. So it's saying x is less than 1. So open circle. And x is greater than 0. X is greater than 0. So, well, that's false because it has solutions. It could be 0 0.1, 0 0.2, 0 0.3, up to 1. So that's false. It has real solutions. The absolute value inequality, the absolute value of x is less than or equal to negative 1 has no real solution. It's true because, like I say, when you're doing an absolute value, the result can't be negative. Okay. So give one of the following. Each number should be used once. So I'm tutoring for a while, and every time I tutor, I let students know that when you see something like this, before you want to start putting numbers in, simplify it. Simplify all your numbers that you see here. So we have this one could be simplified over here. This is negative 3 pi squared divided by pi. We could just divide one of the pi's out and we'll have negative 3 pi. Okay, we can simplify this some more. This is the square root of 2 divided by negative 4. Let me bring this up some more so I get enough space. Which is equal to 1, which is equal to the square root of 1 divided by 2, and it's negative. So that would be that in its smallest form. Then this, anything to the power of 0 is 1. So this would just be negative 7 times 1. This is just negative 7. This is just 0 because the square root of 3 minus the square root of 3, that's 0. That'd be 0 over root 2, which is just 0. The absolute value of negative 5 is just 5. And so let me write these numbers better. Negative 7 times 1, which is equal to negative 7. This is the square root of negative 1 over 2. Okay, make sure everything's simplified. Okay, yeah. Okay, so give one of the following, a non-zero natural number. So a non-zero natural number. Remember, natural numbers are counting numbers from 1 going on into infinity. So we have the absolute value of negative 5. For me, I don't write the simplified version. I write the version that we have here. And since I already used that, what I'm going to do is just cross this off so I don't use it again because it's a use. Each number should be used once. Read your instructions because sometimes they could tell you to list all the numbers that belong to this category. But for this question, it says to that each number should be used only once. So a whole number that is not a natural number, this right here. 0 is not a natural number. 0 is a whole number. So root 3 minus root 3 divided by root 2. Then cross it off. An integer that is not a whole number. Right here. This is negative 7. Why do I look like a negative 1? Negative 7. Negative 7 is an integer that is not a whole number. Remember, our integers are positive and negative whole numbers. So negative 7, root 7, to the power 0. A rational number that is not an integer. Remember, our rational numbers can be written in two forms. This uh, it's our integers and all the quotients of our integers, as well as the terminating decimal or the non-terminating but repeating decimal. So this would be a rational number that is not an integer because even though it goes on, it just repeating. You're saying it just repeating. So when you see a decimal like this goes on but repeats itself, that is a rational number. So 2.343434, and then goes on. Cross this off. An irrational number, negative 3 pi. When you see pi, if you see pi, just know pi has to do with rational numbers. So this, yeah, pi is an irrational number. So negative 3 being multiplied by pi still makes it an irrational number. So an expression which is not a real number, the square root of negative a half, that is not a real number. Square root of a negative number is not a real number. Oh, why am I writing that? Hold on. Let me correct what I was just writing in the last one. Negative, negative 3 pi squared over pi. That's 3 pi. And then down here is the square root of 2 over minus 2. And that should be everything. Okay, the dreaded properties. Now, for this, what I tell students to pay attention to what is happening on the left side. Pay attention to what is happening on the left side and match it to what happens on the right. So, if I'm looking at this, I'm seeing 0 plus open bracket, pi plus 1, right? And then over here, I see 0 plus pi plus 1. I see that over here, we're adding 3 numbers. We had 2 particular numbers grouped, but over here, another 2 numbers were grouped. So this tells me that this is the associative property of addition. That tells us that when we add 3 numbers, we can group them in any way. So associative property of addition, that is A. Okay. Over here, on the left side, I see that negative pi is being multiplied by 1 over negative pi plus 0. And over here, I see the 0 stayed the same, but this whole entire thing became 1. When you see a question like this, you see a number being multiplied by its reciprocal, just know that that is the inverse property of multiplication. That tells you that when you multiply a number by its reciprocal, the product is 1. So this is the inverse property of multiplication. Where is it? Inverse property of multiplication, G. Okay, now over here, we have 0 plus pi times 1. And then over here, we have 0 plus pi. Okay, I can see that pi was multiplied by 1 and it stayed the same. So that is an identity property of 1. This is telling you that when you multiply a number by 1, the result is that number. When we multiply pi by 1, the result is just pi. You see, if we multiply 3 by 1, the result is just 3. So when 1 is multiplied by a number, the result is that number. That's the identity property of 1. So I'm going to cross that off. Okay, over here. Over here, I see that negative pi is being added to pi and then multiplied by 1. Equal to, over here, I see that 1 stayed the same, but this entire thing became 0. This is telling me that this is the inverse property of addition. It basically, when you add a number to its opposite, the sum is 0. That's what the basis of the inverse property of addition is. When a number is added to its opposite, the sum is 0. So this is C. So negative 3 plus 3 is 0. Negative 4 plus 4 is 0. When a number is added to its opposite, the result is 0. Okay, so on the left side is pi times y, and then we add 1, and that's equal to 1 plus pi times y. So when I look to see the difference, this was over here, but now it's over there. Like they're switching around the places. And it's being added, this entire number, even though you're looking at it and you might say, okay, there's 2 numbers. I'm looking at it as 1 number. Because regardless, pi times y will give you 1 number. 3 times 4 gives you 12, right? That's 1 number. So regardless, sometimes you gotta look at it not as multiple numbers, but as 1 number. And if you look at this as 1 number and look at this as 1 number, they're just switching around the places. This tells me that this is the commutative property of addition. When we add 2 numbers, we can group them in any way. We add in this and 1. So because we add in 2 numbers, we can group them in any way. We could add pi times y plus 1, or we could add 1 plus pi times y. So this is the commutative property of addition. B. Okay, so now we have -2 times pi times 1 is equal to -2 times pi times 1 is equal to -2 times pi times 1. So we we have three numbers. We have three numbers, -2 times pi times 1. And these two numbers were grouped. But over here, you see these two numbers are grouped. So this is telling me that when I'm multiplying three numbers, I can group them in any way. So this is telling me that this is the associative property of multiplication. When we're multiplying three numbers, we can group them in any way. That's what that is, the associative property of multiplication. This is E. E. Okay? So now down here, we're adding, we had on the left, we had 0 plus pi in bracket, and then plus 1 is equal to pi plus 1, right? So over here, I see that 0 is added to pi. And over here, I see that it's stated as pi. So this is telling me that when 0 is added to a number, the result is that number. This is the identity property of 0. When you add 0 to a number, the result is that number. The identity property of 0, which is D. And the last one, so we have y times open bracket pi minus 1. Y times open bracket pi minus 1 is equal to pi minus 1 times y. So we are multiplying two numbers, and in the order in which we multiplied them switched around. If you see, at first we was multiplying y times this. Now we're multiplying this times y, you see? So this is the commutative property of multiplication. And it tells us that when we're multiplying two numbers, we can group them in any way. So the commutative property of multiplication, that is F. Okay. Now for this, you really have to take your time. This involves order of operations. So we really have to take our time with this, substitute our numbers, and to make sure that we are following order of operations. Try to refrain from doing multiple steps in your head, because if you do that and you get a step wrong, that might throw your whole answer off. So what we're gonna do is start off by substituting our numbers in. So evaluate the following for a equals -12 and b equals 5, showing all workings clearly. So we have equals 7 minus 5, 1 minus the square root of -12 squared plus 5 squared divided by the absolute value of negative. You see a negative was already there. So we're going to open bracket -12. A negative was already there. So we're going to put our -12 in brackets. Minus b5 cubed, b which is 5 cubed. And then close absolute value. Minus a squared plus -12 squared. Remember, don't forget your brackets. Don't forget your brackets. This should be in brackets too. Divided by 6 times 4 minus 2. Close bracket. Now remember order of operations. PEMDAS. Remember parentheses, exponents, multiplication, division, addition, and subtraction. So what I'm going to do first is I'm gonna square these two up here. So equals 7 minus 5, 1 minus the square root, -12 squared, that's 144 plus 25 divided by, and in the denominator, what I'm gonna do is I'm going to multiply this negative times this 12. I'm going to multiply this negative times this -12, and that will give me a +12. Remember, don't forget your absolute value. That'll give me a positive 12. And then I'm going to raise this 5 cube. 5 cube is 5 times 5 is 25. 25 times 5 should be 125, but always going to be sure to use your calculator so you don't put the wrong thing. But it is 125. So this is 12 minus 125. Okay. And then we're going to do minus negative 12 squared is 144 divided by 6 times 4 minus 2. So you're going to put the rest. Now, 7 minus 5, 1 minus 144 plus 25. 144 plus 25 is 169. So 1 minus the square root of 169 divided by, that's the absolute value of 12 minus 25. 12 minus 25, absolute value 12 minus 125. That's the absolute value of negative 113. Minus 144 divided by 6 times 4 minus 2. So we equal to 7 minus 5, open bracket. The square root of 169, let's check that out. The square root of 169 is 13, so that's 1 minus 13 divided by the absolute value of 113 is just 113, so that's 113 minus 144 divided by 6 times 4 minus 2. And I'm going to bring all of this over because I need space. So equals 7 minus 5. 1 minus 13 is negative 12, so there's negative 12 up there. Remember PEMDAS. We're not going to subtract 113 from 144. We're going to do division first because division comes first. So we're going to put our 113 back. So we have 113 and then negative 144 negative divided by 6 is negative 24. So we're going to put minus 24 times 4 minus 2. Let's put our 2 back there. So equals 7 minus 5, negative 12, divided by, we're going to do multiplication next. So negative 24 times 4. So put the 113 back, and then negative 24 times 4 is minus 96. So 113 minus 96 minus 2. Continue from up here. That's 7 minus 5. Open bracket, negative 12 over 113 minus 96 minus 2. Negative 2 over 15. Okay, so equals this 5 is being multiplied by this entire thing. So we're going to multiply 5 by negative 2. So we're going to have 5 minus 5 times negative 2 is, that'll be negative 10 over 15. So that'll be 5 minus negative 10 over 15. And you see, those are two negatives. Remember, negative times a negative is a positive. So this would be 7 plus 10 over 15. And we can simplify the 10 over 15. 10 over 15, both divided by 5 is 2 over 3. So 7 plus 2 over 3. And to add, you could put this in your calculator and it will give you your final answer. But my calculator ain't dealing with fractions. So let me put this in my calculator. So 7 plus 2 over 3 is 23 over 3. So my final answer is 23 over 3. Okay, about 23 over 3. It's quite a lot of work, but don't worry if you feel like you messed up somewhere. Because even if you don't get your 5 points, if you still follow through until the end and your professor can still see that you understand what you're doing, you're still going to get some points. So don't beat yourself up if you get a value incorrect. Once you still follow the entire format, you're good. I see some people have their hands raised. We're going to ask our questions at the end. So write the question number and any question you may have, and we'll come back to that during the Q&A period. Okay, so evaluate the following using scientific notation. Express answer in scientific notation. So our first step is to convert all our numbers in scientific notation. So we have this first decimal here. To do that, we want to move our decimal from here over. We're going to move our decimal from here all the way over to the right of this 8. So we're going to count 1, 2, 3, 4, 5, 6, 7. So we have 8.8 times 10 to the power negative 7. It's negative because we move to the right instead of the left. When you move into the right, 1, 2, 3, 4, 5, 6, 7, it's negative. And then we're going to put the other values back there. Now we're going to put this as a decimal. To do that, you have that's 40,000. So we have 40,000. And we're going to put our decimal right here, right? And we're going to move this decimal point. We're going to move this decimal point all the way over to the right of 4. So we're going to move 1, 2, 3, 4. We moved it 4 times. So we have 4 times 10 to the power of 4. It's positive because we moved to the left. I see your questions in the chat. Like I said, I'm going to answer all of them during the Q&A period. So 4 times 10 to the power of 4. And then times 2 times 10 to the power of 126. Okay, so now we're just going to switch our numbers around a bit. So 8.8 times 9.5, because we're going to multiply all the 10s with each other and then all the other numbers with each other. So 4 times 2 times 10 to the power of 4 times 10 to the power of 126. So now we're going to multiply 8.8 by 9.5. So 8.8 times 9.5, that's 83.6 times. So this is the product rule. So when you add in two numbers, when you multiply in the same base and with the exponents, you add the exponents. So we have 10 to the power negative 7 times 10 to the power 12. That's 10 to the power negative 7 plus 112, which is equal to 10 to the power of 112 minus 7. That's 105. So 10 to the power 105, right? So you have 10 to the power 105 in the numerator divided by 4 times 2 is 8 times, that's 10 to the power of 130. Because if we have 10 to the power of 4 times 10 to the power of 126, that's 10 to the power of 4 plus 126, which is equal to 10 to the power of 130. Yes, 130. Okay, 105. Why I just have 5 there? Okay, so now I gotta move this over because I need space. Okay, now we're gonna divide. So 83.6 divided by 8. 83.6 divided by 8 is 10.5. So that's equal to 10.45, right? And then we have 10 to the power of 5, 105, divided by 10 to the power of 130. So that could be 10 to the power of 105 minus 130, which is equal to 105 minus 130, which is equal to 10 to the power of negative 25. So you have 10 to the power of 10.45 times 10 to the power of negative 25. But this isn't the final answer. That isn't the final answer because this 10, the number that you have here is supposed to be less than 10. If you can see, this is more than 10. So what we're going to have to do is we're going to have to move this decimal place over once. And when you move this over once, this is going to be equal to 1.045, right? And that one that you move it over, you have to add it to this exponent here. So negative 25 plus 1 is negative 24. So times 10 to the power of negative 24. And that would be your final answer. So simplify the following algebraic expressions. So for this, it's a little tricky, but you want to start from the inside out. So you want to start from the inner grouping all the way out. So inner grouping all the way out. So you're going to just start multiplying from the outside. So 2x, open bracket, x squared. You're going to multiply this minus 5y by x. So that give you minus 5xy. Then you're going to multiply this minus 5y times this negative y. That'll give you positive 5y squared. And then minus 5y, open bracket, x squared. You're going to multiply this negative times both of these terms. So negative times y squared is minus y squared. And then the negative times minus 2xy is plus 2xy. Close bracket again. And I didn't close bracket over here somewhere. It's supposed to end close bracket right there. I'm going to use our equal sign. So equal, that bracket, what I put there, that came from over here. After I multiply minus 5y times minus 5y squared, I got positive 5y squared. And then I'm supposed to put the bracket back. Okay, so now we have to simplify some more. None of these have like terms, so this can't simplify no more. We could just multiply this 2x to the entire equation. So 2x times x squared is 2x cubed. 2x times 5xy, that'd be minus 10x squared y. And then 2x times 5y squared, that'll be plus 10xy squared. Then minus 5y times x squared would be minus 5x squared y. Minus 5y times negative y squared would be plus 5y cubed. And then minus 5 times 2xy would be minus 10. X y squared. Okay, Now, there's a lot of stuff, but just bear with me. Now, we want to look for our like terms. So we have 2x cubed. We don't have no other x cubed. So we're going to just put it back. So it equals 2x cubed. Let's look for x squared y. Do we have any other x squared y? We have this x squared y. So minus 10 x squared y minus 5 x squared y. And then we have plus 10x xy squared. So plus 10 xy squared minus 10 xy squared. And then plus 5y cubed. Okay, so now let's simplify. So that's equal to 2x cubed minus 15 x squared y. This would be 0. 10xy squared minus 10xy squared is 0. Plus 5y cubed. So the answer is 2x cubed minus 15x squared y plus 5y cubed. And let me just check, make sure I made no errors. 10x squared y. So 2 times 2x times minus 5x squared is minus 1 squared. Okay, I don't see no errors. So okay, so this will be with your exponents. So this will really be testing your law of exponents. So your first step would be to raise this -2 to all the factors. So 3 to the power -2, x to the power, that'd be -6, because 3 times -2 is -6. Y to the power +10, z to the power -2, divided by 2 to the power -1, x to the power -6, y to the power +4, c to the c squared equal. Okay, so equal. Your next step would be to subtract the quotient rule. So if you have x to the power -6 divided by x to the power -6, that's equal to, let's move this over here. That's equal to x to the power -6 minus -6. Remember, the quotient rule is when you subtract the two exponents. It's already a negative, so you have to put the minus in the middle. If you don't, you're going to get an incorrect answer, which is equal to -6 plus 6, which is equal to 0. So this would just be x to the power 0, which is just 1. Yeah, which is just 1. Okay, and then y. So if you have y to the power 10 divided by y to the power 4, this is equal to y to the power 10 minus 4, which is equal to y to the power 6. Then c to the power -2 divided by z squared is just equal to z to the power negative 2 minus 2, which is equal to z to the power negative 4. Okay, so now we're going to put all our values back. So we have 3 to the power negative 2, and then y to the power 6, and then z to the power negative 4, divided by 2 to the power negative 1. Our instructions were to simplify it, to simplify the following algebraic expressions. Normally, they don't want you to leave no negative exponents. So to get rid of these negative exponents, switch their places. So put this in the numerator, put this in the denominator, put this in the denominator. So now we have 2 y to the power 6 divided by 3 squared, c to the power 4. And let's bring this up some more. So our final answer would be 2 y to the power 6 divided by 9 c to the power 4. Hmm. Okay, so now solve the following expression. So my first thing that I want to do, since I have fractions and since the denominators are two different values, since we have fractions and denominators are two different values, what I'm going to do is find the LCD of 3 and 2. So the LCD of 3 and 2, so 2, 4, 6, 8. Then we have 3, 3, 6. LCD of 2 and 3 is 6. So I'm going to multiply this entire equation by 6. So we have 6 times 2 minus 6 times 2 over 3. And that being multiplied times 1 minus 5, 6 equals 6 times 4x plus 1 over 2. So 6 times 2 is 12 minus 6 times 2 is 12 again. So that's 12 over 3. 1 minus 5x equals, you have 6 open bracket 4x plus 1 divided by 2. That's equal to 12 minus 12 over 3 is 4. And then 1 minus 5x, which is equal to, we have 6 divided by 2, which is 3. So we just have 3, 4x plus 1. Okay, so now we want to distribute our values. So distribute these values. So we have 12 minus 4 plus 20x is equal to 12x plus 3. Simplify, so 12 minus 4 is 8 plus 20x is equal to 12x plus 3. We want to send all our x's on one side and all our constants on another side. So bring this over some more. So 20x minus 12x is equal to negative 8 plus 3. So I brought the 12 over and it became a negative. And I brought the 8 over and it became a negative. So now we have 12 minus 20 minus 12 is 8x. So 8x is equal to negative 8 plus 3 is negative 5. So x is equal to negative 5 over 8. Okay, let's make sure, let me see. Make sure. If y'all think y'all see me, you can send it in the comments. But at this point, I don't see nothing, so moving on. Okay, when you have an absolute value question, what you want to do is isolate the absolute value. So First thing I'm gonna do is transpose and send this 3 over here. It's positive here, but when I send it over here, it's gonna be negative. So we have negative 5, absolute value x divided by 2 minus 1 equals negative 32 minus 3. Then we have negative 5, absolute value x divided by 2 minus 1 equals negative 35. I'm gonna divide both sides by negative 5. That's gonna give you x minus divided by 2 minus 1 is equal to negative 35 divided by 5, that's positive 7, I believe. Check the calculator. 35 negative divided by 5 negative is positive 7, yeah. So now you're going to have two answers. X divided by 2 minus 1 is equal to 7, or x divided by 2 minus 1 is equal to negative 7, right? We have fractions again. So we're going to multiply the entire equation by 2 to get rid of this fraction. So we're going to have x minus 2 equal 14. When I multiply this by 2, it divides out, and I'm just left with the x. 2 times 1 is 2, 2 times 7 is 14. I'm just going to solve for x. So x is equal to 14 plus 2. X is equal to 16. Again, to multiply the entire equation by 2. X minus 2 is equal to negative 14. X is equal to negative 14 plus 2. X is equal to negative 12. Or, so either x is equal to 16 or x is equal to negative 12. Okay. Next question. So solve each of the following inequalities and graph each solution set on the number lines provided. So we have a fraction. I'm going to get rid of this fraction. So I'm going to, since it's only one fraction of 3, I'm going to multiply the entire equation by 3. So when I do that, I would get 6 over 3, open bracket x minus 13, less than equal to, that'd be negative 6, 1 minus x. So 6 divided by 3 is 2, x minus 13, less than equal to negative 6, 1 minus x. Now I'm going to distribute. This is going to be 2x minus 26 less than equal to negative 6 times 1 is negative 6, and then plus 6x. 2 times x is 2x. 2 times negative 13 is negative 26. Negative 6 times 1 is negative 6. Negative 6 times negative x is positive 6x. I'm going to send the 6x over. That's going to give us negative 6x plus 2x. I'm going to send this 26 over. Yeah. Less than or equal to, that's going to give us negative 6 plus 26. Now we're going to have negative 4x, because negative 6 plus 2 is negative 4, less than or equal to 20. Negative 6 plus 26 is, negative 6 plus 26 is 20. Going to divide both sides by negative 4. When you divide by a negative number, please do not forget that the sign switch. When you divide by a negative number, please don't forget that the sign switch. When you sending your questions in the chat, don't forget to make sure I put the question number, so I can come back to it. So when you divide in both sides by negative 4, but by a negative number, flip the sign. So this will now be x is greater than or equal to 5, negative 5. Because 20 divided by negative 4 is negative 5. Remember, you always need to use your calculator. I use my calculator for simple math. So it's easy to get trip up. So it's saying that x is greater than or equal to negative 5. So let's put our values. We have negative 6. Let's put negative 6, negative 5, negative 4, negative 3, the value thing already there. -6, -5, -4, -3, -2, -1, 0, 1. So it's saying x is greater than or equal to -5. So closed circle, pay attention to what kind of equality is there. It's greater than or equal to, so we are going to be a closed circle. And since x is greater than -5, I'm going to go this way. X is greater than -5. Okay. Okay, this is similar to that kind of, not too similar, but almost similar. Fraction. So the first thing we're going to do is get rid of this fraction. To do that, we're going to multiply the entire equation by 5. So you're going to have -5 less than or equal to 3 minus 2x less than or equal to 5. Next thing we're going to do is we're going to add, we're gonna subtract 3 from the entire equation. Since it's positive here, to get rid of this 3, we have to subtract the 3 to make it 0. So we're gonna have to subtract 3 from the entire equation. So that's -5 minus 3. That's gonna equal to 3 minus 3 minus 2x less than 5 minus 3. Simplify, that's -8 less than or equal to -2x less than 2. Now we're going to divide the entire equation by -2. Remember, when you divide by a negative number, the sign flips. So this is going to be -8 divided by -2. Divided by a negative number, the sign flips. -2 divided by -2x. 2 divided by -2. Let's move this over some. So -8 divided by -2 is +4. That's +4 less greater than or equal to x greater than -1. So I'm just going to rewrite it so it will look like sense. So that's -1 is less than x is less than or equal to 4. So x is less than or equal to 4, but greater than or equal to -1. So I'm just going to put 4 here. 3, 2, 1, 0, -1. So make sure close circle because it's greater than or equal to, so close circle. There's less than over here, so open circle. Make sure you put in your right circles and connect it since it's and x. Now this is an OR problem, so you know it because you see this absolute value here and the sign going this way, so you know that's an OR problem. So 2x plus 3 is greater than 1, or 2x plus 3 is less than -1. So your two answers when it comes to that. And then you're going to solve for x. So 2x is greater than 1 minus 3. 2x is greater than plus -2. X is greater than divided by 2, that's -1. Or 2x is less than -1 minus 3. 2x is less than -4. X is less than -2. So x is greater than -1 or x is less than -2. So I'm just going to put my -2 here, and then -1 here, -3, -4, -5, 0, 1, 2, 3. X is less than -2. Open circle, remember, be mindful of the circle you're using, x, or x is greater than -1. Open circle, go this way, x. So we should have two answers. Literal equations. Okay, so literal equation is the equation that contains variables other than the one we are solving for. So we want to solve for x. So it might look like a lot, but be mindful that when you're a pro and you're taking the assessment, you're not doing anything you haven't seen before. So just apply what you know. So we have 5y minus, we're going to distribute the 3 to both. So minus 6y plus 15xy equals 4x minus 3. 4xy minus 3. Okay, so now simplify. So 5 minus 6, that's negative y plus 15xy equals 4xy minus 3. We're going to send all the x's on one side and all the variables with the x's on one side and all the variables that don't contain x on the next side. So this would be negative 4xy plus 15xy is equal to negative 3 plus y. Negative 4xy. Send that over here and then send the y over here, that'd be positive. We could simplify these two because 15 minus 4 is 11, so that'd be 11xy is equal to minus 3 plus y. You're going to divide both sides by 11y because we want to isolate the x. So x is equal to minus 3 plus y divided by 11y. Okay. Okay, the dreaded word problems. In the following, use x to represent an unknown real number. Write each English phrase as an algebraic expression. So 10 diminished by a number. Diminished. Hold on. So 10 diminished by a number. Diminished. When I hear diminished, I think in going down. So becoming less. So I'd say 10 minus x. 7 greater than a number. So 7 more than a number. How do you get 7 more than something? Add 7 to it. So 7 plus x. The quotient of a number and 3. So the quotient of a number is like, when you divide a number by another number. So the quotient of a number and 3 is x divided by 3. The product of 4 and a number. Remember, product means multiplication. So 4x. The square of the difference of a number and 5. So it's quite a few. When you see in this of, that means that's like an operation happening inside of something. So we're saying the square. So let me put my brackets and it's saying, because it's a square. So the square of the difference of a number and 5. So the difference of a number and 5. So the square of the difference of a number and 5. So that's what this is. And I believe this is the last question. So the length of a rectangle is 7 less than triple its width. If the rectangle has a perimeter 154 feet, find its length and width, solve algebraically. So we're going to do our rectangle. Let's say the length is 7 feet less than triple its width. So length is triple width minus 7. It's a 7 feet less than triple its width. So we're just going to put our width here. If the rectangle has a perimeter of 154 feet, find its length and width. Okay. Remember, our perimeter is our distance around the figure. So perimeter is when you add up all the sides. So width, and then width over here, and then remember the length over here would be 3w minus 7. So we just said 154 equal to 2 times 3w minus 7 plus 2 times w. And solve. So 154 is equal to 6w minus 14 plus 2w. 154 is equal to 6w plus 2w is 8w minus 14. Gonna send the 14 over. So that'd be 154 plus 14, when you send it over, it's going to be positive. Transpose, new transpose is going to be positive. Is equal to 8W. 154 plus 14, that is 168, is equal to 8W. Now we're going to divide 168 by 8. So W, so that's 21. So 21 is equal to W. So your width is 21. But don't stop here because you only found the width. You need to find the length. Your width is 21. Remember your length is 7 less than 23 times your width. So length is 3 times 21 minus 7. L 3 times 21 minus 7 is 63 minus 7. So 63 minus 7 is 56. And then to see if it's correct, just add it. So 2 times 56 plus 2 times 21. 2 times 56 is 112 plus 42 plus 42. That's 154. And that is the parameter. So this is correct. Okay. So I hope I was recording. This thing was recording? Yeah, recording. Okay, sorry. Okay. Let me see where the recording will be uploaded. The recording will be uploaded to YouTube. Okay, so let me stop sharing. Start my video. Okay, y'all can see me. Hi again. All right, so before we get into the Q&A, let me just tell y'all about the resource that we created. So I'm going to share my screen from my laptop. So give me a thank you so much, 03014. Thank you so kindly. Let me just get my laptop and I'm going to share my screen from my laptop to show you all the resource that I created that I was promoting. Okay, so give me a second. These tools, share screen. And math 140. Okay. Okay, so share my screen. Okay, turn off my video. Okay, y'all should be able to see my screen. Okay, so like I said, I am a part of the Miss and Mr. University of the Bahamas pageant. I'm vying to be your next Miss UB to make more resources available for students, in math, to help students improve their numeracy skills and understand difficult math concepts. So I created this resource for Math 140. I created two versions. The first one is the complete booklet, and I will show you throughout the booklet. So my platform is entitled The Confidence Equation. So this is me. I'm on my pageant journey, and that's my platform down here. A campus-centered math empowerment platform designed to help UB students improve their numeracy skills, understand difficult math concepts, and rebuild trust in their academic abilities. So I spent my New Year's and Christmas, preparing to create this book, create two other different courses. So inside this book, we have a table of contents and we have all of the topics that will be available. We have all the topics that will be available that will be on your test one, right? So up from real numbers up until the concepts of functions. So all this would be on your test one. This booklet is to help you prepare for your test one. So we have the notes. that I used from my own personal notes from when I took the course. And then at the end of this is a YouTube playlist, right? So click on it, and it takes you to a number of YouTube videos that will assist you with the course. So let's go back. Let's go to a number. Let's go to another. Let's go to another chapter. So this was one of the things we was doing in the on the past test one. So a lot of practice questions. So let's go to the next one down here. So absolute value. So you see absolute value. So it's notes to help you understand what absolute value is. And then, like I say, playlist, click the playlist. It takes you to a playlist to continue explain absolute value to you. So you see, and that's this all throughout the booklet. The practice questions. Okay, so this is the first version, right? The next version is just the completed question booklet. So let's just say you don't want all the notes and stuff, right? You have the question booklet with just the practice questions. So it would just still table of contents and it's showing you the topics and the practice questions. So let's say you have your own notes, you don't want my notes, you could just take and get the practice questions that are there. And that's it. That's just practice questions. So these two booklets are available for purchase. All the funds that are raised from these booklets will be put towards helping me within my pageant journey. So the completed question booklet is $25 and it's a PDF. So I'll be emailing you the PDF. And then the question booklet is just $10. So whichever one you prefer, PDF, I would email, you would pay. I'd email it to you and you get started on using the booklet and helping you prepare for your test one. So if you're interested, I would put my number in the chat and you can message me to get access to the booklet. 4380631. So yeah, like again, it's PDF. So I'll send you the PDF and you could print it out on your UV prints if you'd like, or if you have an iPad, or you could just write the question and answer. So yeah, and also remember that the university provides free tutoring and I am one of the pair tutors. So if you get it, we can work on the questions together. So even if you don't want it and you still want to know more about the free pair tutoring, still message me so I could send you all the pair tutors that are available. Because we have 3 pair tutors that are available for Math 140. So that is it in regards to this. So let's get back into that so we could talk about the question and the questions that you have. So now we're on the Q&A. Share screen. So I think that's, let's see, those tools unmute. Okay, let's see. Jemiah is in here, so, and I don't know what she meant by that. Okay, Trinity Roker. Trinity, you could unmute your mic if you want. Question 4, where you got -2 in the denominator, yuck in the numerator. Question 4, Trinity. Trinity, you wanna expound on the question? Let me see if I can see what you're talking about. 4, but you got 2 in the numerator.
Yeah, sorry, good night.
Good night.
In the 1,
Oh my
2, 3, 4,
gosh,
5,
yes,
6, 7.
you are right. That's not supposed to be a 2. It's supposed to be a 12. Where I got 2 from? It's supposed to be -12. And where I got 10. Okay, so that's supposed to be -12. Because the -12 was down there.
Okay, thanks.
Yeah. So now we gotta finish that off. So I'm supposed to be the answer. So equals 7. 5 times 12. Let's see. 12 times 5. That's 60. So that'd be positive since it's two negatives. So it's 12 plus 60 over 15 equals 60 divided by 15 is 4. 7 plus 4. So this is equal to 11. Okay. Thank you so much for that mistake. So see, errors are, even with me, I've been doing this for like years. Sometimes you can't tell what's happening, but just know that even if you make a little mistake like that, you get like 4 points, 4.5 if they feeling generous, because that was just a little one little error. Your lecturer could see you know what you're doing. You just made a little error there. You see what I'm saying? So I don't want y'all to beat yourself up. Once you know what you're doing, you're gonna be fine on your exam. Okay. Number 4, Denari Lloyd. Denari, are you here? Denari, is Denari here? Yeah. Denari, how are you? What do you mean by why did 5 get multiplied but not -5 for number 4? Let's see.
Good night.
Good night.
So yeah, that same question when it says equals 7, take away 5.
Mm-hmm.
I thought it was gonna be like -5 times and then negative
Technically,
12 over 15.
yes, that's what I did do. See, negative times negative is a positive.
Right.
So, answer your question, or are you still confused?
Yeah,
Because
that
I'm
answered my question. I was just a little bit confused during the beginning.
okay, no problem, no problem. Okay, so let's see the next question. Latrell, are you here, Latrell? Paging Latrell. Latrell Stewart. Is Latrell here? Yes, Latrell, you're here. Latrell, unmute.
Good night.
Good night. How are you?
I'm good.
That's wonderful. How come you didn't use the 1, number 7? Let's see. What do you mean? What one? Hello? Latrell, you
Oh,
here?
no, I'm looking. You can go back.
Okay.
I think it was the question before this. This isn't it either. You go back down, please. Okay, I don't see it, so I might have been wrong.
Okay. All right. So, okay, then. I guess no one else has any more other questions. If not, thank you. Let me do my camera. Okay. Share. My camera on. Let me see my camera. Hold on, let me see. Is my camera on? Okay, it on. Thank you so much for joining. I really hope this session is beneficial. What I'm gonna do is I need to review to make sure that all of these questions were accurate. When it's accurate, I'm gonna upload. I'm gonna upload the video onto YouTube. So if you want to come back and review it, and if I have to make any changes to anything on the document, I'll put a little asterisk there to let you know that, okay, I had to make a little change because I probably made an error or mistake there. But yeah, even if you're not getting the results, still message me on the number I put in the chat to stay updated for when I'm doing more activities for Math 140. So take my number 242-438-0631 and just send me a message and I'll add you to the broadcast for when I have in, my Math 140 activities. Thank you so much for joining, guys, and y'all have a wonderful evening.
You repeat your number again from Bliss.
Pardon?
Repeat your number for more again.
It's in the chat 438-0631. Make sure put 242. 242-438-0631.
All right, thanks.
Okay, no problem.